So good afternoon. It is now 12 o'clock of our Real World Wednesday speaker series, and we're back again. I'm Dustin Seaton, the gifted and talented specialist at the Northwest Arkansas Co-op.
Hi, I'm Carly Janolis. I'm the science specialist here at the Northwest Arkansas Education Co-op.
And I'm Jenny Gamble, and I am the elementary STEM specialist at the co-op.
And before we introduce our 12 o'clock speaker, I will remind all those that are watching at home or in class that you don't have to unmute, turn your videos on or off. We're using the Zoom webinar feature. So if you have a question at any point, feel free to use the chat to make comments or the Q&A box to ask our speaker today questions about his profession. You're in for a treat. He came highly recommended. So I want to turn it over and let Kaushik Ramini introduce himself and give us your quick intro.
Yeah, so I'm Kaushik. TLDR, I'm a university student at the University of Arkansas. I'm a mechanical engineer. I'm the co-founder of More Technologies, and I'm also a mechanical engineer at Sphera. And so, the past 4 years I've gone from UArk student, entrepreneur, full-time employee. So it's been quite a journey. So a little bit about, I guess what More Technologies is. It's a company founded my sophomore year of college. It was just me and a couple of buddies. And, it started with the three goals of one, to start a robotics company that is more intuitive for kids to quickly pick up and understand with no prior building knowledge. Just get it out of the box. You need to know the pieces. You can just kind of figure out what it does. It's significantly easier for teachers to design lessons around to teach those important concepts, especially because teachers are always limited by the clock. So the quicker that they can get things set up and taken down, the more that they can teach. And significantly more affordable than the competition because all the alternatives out there on the market at the time were very cost prohibitive. And so the main reason for those goals is to lower the barrier for schools to implement robotics and STEM education into the classroom so that more students and more schools can have access to that type of stuff because that really is the future. And so our solution, so let me share screen. Okay, so this is what we came up with. So this is Morbot. So it was a 3D printed modular scalable robotics platform. Cool. What does that really mean? So this right here is what we came out with. So this is just like our basic robot, and it's made up of all of these building blocks. And every single plastic piece you see here is all 3D printed. All of the electronics are openly sourced and easily sourceable. And then all of the connecting pieces are wooden dowels. So it's super cheap and super easy if you break one of the wooden dowels. Just go get more. You can cut them to any size you want. All the parts are 3D printed, so that keeps the cost down from our end for manufacturing. But also a lot of schools now are implementing 3D printed education into their curriculum. And so it'd be really easy to build off of this. And everything's kind of designed with education in mind. So, you can kind of 3D print a connector to anything, right? But we spent a lot of time trying to make our internal geometries very simple. And so it's kind of like, as long as you can design a square, you can design something that attaches to this because everything's cubular, everything's a square. You don't have to worry about tolerances or anything. We do that on our end. So yeah, and then, that kind of company grew. And over time, as it grew, it started to grab the attention of another company called Sphera Little Bits. And Sphera Little Bits is a robotics company that focuses in the same type of thing. They're educational robotics. They make much more standalone robots at the moment, like these guys over here. So like this guy is one of the more famous ones. It's like Bolt. It's like a STEM toy that rolls around. You can teach coding. It's got sensors and everything. This is one of the more recent ones. It's called Indie. It's meant for like the lower grades. It's essentially like a robot that teaches code without needing to do any code because you have these plates that it goes over that are all different colors, and each color corresponds to a different action. And so, green means go, red means turn right, blue means turn left, whatever. And so little kids can like lay these out on the classroom and then like start designing mazes and you start understanding logic flow and conception and planning. And then you can even go in more depth and actually reprogram what each one does, each of the tiles. So that's just a little bit about an overview of what Sphera and More is. I can get more into that later, but I figured it would kind of be worth taking a step back and kind of going through how did I get here? I'm pretty young compared to most.
How old are you?
Yeah. So,
Yeah, I gotta know how, because we're all sitting here close to 30s and 40s. How old are
Yeah.
you?
Yourself, Jenny.
yeah. So
Okay, that's right. I'm the oldest one on here.
I started more technologies my sophomore year in college, so I was about 19. And then the company got acquired whenever I was 21. Now I'm 22. So yeah, it's quite interesting whenever you have an investor be like, "Hey, let's go meet at this one place," and I'm like, "Oh, I can't. I'm not allowed in there. I'm not 21 yet." So, but this is an interesting conversation. But yeah, like I'm obviously super into robotics and super into mechanical design now, and I really know what I want to do. But definitely was not always that way. I didn't kind of just wake up one day and was like, robots, that's my thing. I was kind of always into technology and always kind of into cool concepts, but not significantly more than the average person. I was just like, this is cool, and that's it. But whenever I got to high school, I went to BHS. One of the things that really opened my mind was my freshman year. I took IED, Intro to Engineering Design, and that class is all about just kind of laying the foundation about not necessarily how engineers think, but also kind of changes the way you look at problems, and it's just a different way of thinking. So a good example is people who understand code, right? But one of the most difficult things about learning programming is everything's very sequential, and you have to kind of understand how programs flow. And once you kind of understand variables and logic flow and patterns, you kind of start to understand how to take problems and make them into code. When it comes to engineering, some things are very similar. And so when it comes to 3D modeling, it's kind of like, well, how do I take this three-dimensional thing and break it down into a bunch of 2D steps, and how do I sketch that, and how do I design it, and all of that? You start looking at the world in a different place. And once you kind of adopt that mindset, it really opens your mind to, these crazy cool things. And so that was like the first thing. And especially whenever I got into 3D printing, because we also had a 3D printer at the school, I just thought it was so cool. Because most of design and everything we do in school is all on paper, and it's all theoretical. And it's like, yeah, I'm designing this thing in the computer, and it's all digital. And yeah, I'm just drawing this thing on a piece of paper and making some sketches. But seeing something that you design in a computer interact with digitally, and then being able to fold it and play around with it and feel it, that is just such an amazing experience. Because not only can you get a much better understanding of what it is that you actually just designed, but it's also just like that kind of light bulb moment. Another pretty notable one was physics. Whenever I took physics in high school, I took AP Physics 1. I was not great at physics, but I had an amazing teacher, absolutely amazing teacher. And, it kind of made me realize that you don't have to be the smartest or, the best at something just to find it interesting. It's like, that's cool. And physics really tried to connect the dots of how different things interact, and the basic fundamental concepts of how the world interacts, how the building blocks of mechanical design and stuff like that. And that kind of progressed into IED, DE, POE, and ED. Those are all the other classes at the engineering classes at BHS. And that again, led the foundation to grow that skill set. And then a big thing happened whenever I went from high school to college. Whenever I went to college, I was leaps and bounds ahead of everyone else in the engineering program, because for a lot of people, this is the first time they've been seeing any of this stuff, right? And so they have to relearn that mindset, relearn the thinking, and it's a huge challenge. But for me, it's I was already encountered all this stuff at BHS, and so I had a really good foundation of all this. And because of that, that kind of opened another door where the University of Arkansas has a NASA RMC team, which is essentially a NASA-sponsored competition where college students get to come together and build the next Mars rover, or I guess now it's the Moon rover, they changed it. But at the time I was doing it was Mars rover. And it was a super casual thing, it was during intro day, and we were going around all the students, and I was just got in a conversation with the guys from the team, and usually it's a senior level design project. And he was like, you can kind of come to the next event if you want to just see how it goes. And I was like, that's super cool, because I don't even know anything about design, but here I am being on this team. And it was just so cool, because now it's I'm designing robots that's going to be in NASA. it was a really fun experience. And that's actually where I met my co-founder, Cannon, where he started more technologies with me. And it kind of came to me with the idea of, I want to build something better than the existing platforms we've used before, but the issue is so cost prohibitive to bring it to market, and especially hardware products require investment capital. And so the solution we kind of came up with was 3D printing. And that's kind of one of the reasons he reached out to me too, because I had a lot of experience with 3D printing. And so that was really cool because it's like you're utilizing this new technology and this unknown technology to design something new. And it started out really as this small side project at first, not taking up too much time. And then as the company started to grow, started taking up more and more time, eventually more time than college. And all of a sudden I'm spending more time on this company than college, which was not great for my grades. And so, initially came to a breaking point where I had to make the decision of, how much do I want to cut back on each? And around that same time was when we first got our first initial big investment from an investment company. And that's when I was like, okay, physics 2 will always be physics 2. Even 10 years down the line, I bet it's going to be taught by the same 80-year-old professor who's 10 years here. The curriculum's not going to change. Like, I can always come back to this opportunity with college. But this right here, I'm not going to walk away from this because it's not going to be here whenever I graduate. And so I took the leap and went part-time for my university and then full-time at the company. And that's kind of like how it grew into what I was saying earlier about getting acquired by Sphero. And the rest is history there.
Yeah, that's awesome.
Wait, so did you graduate or are you still working on your degree?
So that's actually really interesting. It eventually went from like part-time to less part-time to less part-time to the point I was like taking one of the largest classes, and I dropped out altogether. And then once we got acquired by Sphero, now that like I don't have to do everything at the company, I can just focus on engineering design, I'm actually going back to school this next semester. Okay. So right now I'm still part-time as a student, but this next semester is going to be my first time back, which I'm super fortunate that Sphero is so flexible as a company.
That's awesome.
So yeah.
I've got lots of rapid fire questions for you. You ready for this?
Mm-hmm.
All right. Shaylee asks, what's it like to be a co-founder at such a young age?
It's definitely interesting. I feel like to start a company, sometimes you have to be very ignorant about what it takes to start a company. So it's a lot of work. There's a lot of high highs and very low lows. But yeah, the entrepreneurship community in this area is really nice. And there's a lot of resources available to us. It helped that I was a college student at the same time, that added credibility. And, after starting a company, it kind of teaches you all of the aspects of whatever you're working on. It doesn't have to be engineering. It's like, I can design a product. It's like, well, if I'm designing something, I have to know the cost implications, and I have to know the consumer base a little bit. I have to know what this is like for investment capital and how that affects our design timeline and like big company ideas and how this fits into the project. And so even just working on a project, you become a much better engineer or designer or whatever you are doing because you understand all the other aspects of the business. And it's really difficult to do that whenever you're just, a cog in the system. If you're a low level, entry level job.
No, good point. Samuel asked a question in Rogers that I also, as a gifted and talented specialist, were you in the gifted and talented program in Bentonville?
I was not.
I wasn't either.
Really interesting point. This is a really interesting point because one of the things that I think is really important to understand is you don't have to be smart. You just have to be hardworking and interested. And as long as you're, passionate or interested at something and you are hardworking, you will find your definition of success. And that definition of success is like different for everyone, right? Doesn't have to be, I'm going to be a millionaire, live in a big house, or say, be like helping people or doing what you love doing, whatever that means to you. I remember pretty distinctively, I've had some great teachers that directly have impacted where I am now. But one of the most notable, in not a great way, was in 10th grade, my high school math teacher came up to me one day and said, hey, I really don't think you should take higher math classes. I actually don't think you should pursue a career that involves math. And I was like, wow, that that's that sucks.
Yeah.
Okay. And luckily I had some pretty great mentors at the time, especially my engineering teacher at the time. She was like, "That don't listen to that. That's BS." And it wasn't later till I realized, there's always going to be people like that. And like, yeah, okay, in a narrow field of view that, there's always going to be those types of situations. But yeah, it's like, I don't know how to explain it. You don't have to be the best at it to be good at it.
Right.
Yeah. Excellent.
That's great advice. That is incredible advice. Kids out there, if y'all are listening, you don't have to be the best at it.
Right. Just keep trying.
Yeah.
So Sawyer and Rogers in Miss Daniels' class also asked, what makes your Sphero job fun for you?
I would say, it's similar to what I was doing at Moore, except at a whole different scale. And so, what I love doing is product design and 3D modeling and, bringing products to market. And whenever I'm working at Sphero specifically, I have a really unique opportunity to be working with some really great industry veterans. I mean, it's really, special to me because I'm directly working with the people who designed the platforms that taught me robotics. And I'm not sure how many other people could have that same revelation. And so the amount of things that I learn every single day when I go into work it's breathtaking. And whenever you're surrounded by people that are so much smarter than you and also very much willing to help you, it's just like so cool because you progress so much faster as an individual, and it just makes everything more fun.
No, that's great. Barrett and Rogers also asked, what's your favorite thing that you've ever built and why?
My favorite thing that I've ever built. That's a good question. Actually, I have a good response to that. It would probably be this guy. So this right here was just like an explanation. We would take this to conferences, and it's like a giant humanoid suit completely built out of the robot platform, kind of to show how like a robot this small can also scale to this big. And that was just always like a huge crowd pleaser. And wearing that thing is incredibly uncomfortable. But like everywhere we went, we'd always have press coverage and like crowds of people coming and asking us what the heck that is.
Yeah.
Because and it was really unique because the way this started was actually really interesting. Because this is like a giant 10-foot robot. You're going through a conference center, and everyone's paying like massive amounts of money for these huge booths, and we're just walking around. We're like a moving exhibition booth. But the way this started was, I think it was like in 2019. We were super scrappy founders. We went to I think it was TCA. It was some education conference. Our hotel was super far away from the event center, and we had like a bunch of demo robots that we had to like take from the hotel to the convention center. And so we're like, okay, well, instead of Ubering, these scooters are now a thing. This is a new thing. Let's ride the scooters. But our hands were all full from carrying robots, and so we ended up doing was strapping robots to our back so that we can ride the scooters to the conference. And then the moment we got to the conference, everyone was asking us questions, like way more than the people who actually paid for booths. We just paid for regular tickets. And they were like, this is a great marketing idea. You guys are genius. Wow. And we're like, yeah, this is all just a marketing ploy. And so ever since then, we've like just been one-upping ourselves. And so it went from like, having this small robot to our back to having a drone on our back, and then eventually culminating into this giant 12-foot tall humanoid robot suit.
Well, and along the same lines, so like Avery and Ellie and Rogers asked, who do you make the robots for and how often do you make them? So like the robot that you just pictured, was that for a project or is that for a design?
Right. So this right here is a kit that we sold. This was like the starter kit. What we designed was like a platform. And we designed this specifically for teachers and sold it specifically to teachers. So right now, this right here is no longer in production because this and all this IP have been acquired by Sphero, which is where I'm working now. But there's still a lot of legacy products. I think we're in all 50 states and like 39 countries right now. The Morbot platform, that is. But yeah, initially it was targeted towards students and teachers, especially the more the teachers that are kind of willing to make their own curriculum, because that was kind of we're engineers, not teachers, and so developing that curriculum is always really difficult. But we found a lot of great success with like those teachers who found it cool, used 3D printing in their classroom, and wanted to develop cool curriculum around it.
No, that's awesome. And that's honestly
Yeah.
what we feel like at the co-op. Education's moving towards, it's more organic, self-grown curriculum,
Right.
with student focus in mind, where it's not just the old bread and butter textbook type stuff. So
Right.
getting kids hands-on with robots and STEM is definitely the future. I don't want to deter. I know you have some stuff that you prepared for, so we can hold off on some questions if you've got things that you want to highlight specifically, like fun stories or the best part of your job, anecdotes.
Oh yeah. I guess I don't know what order you want me to go, and you can just ask them whatever.
I
whichever
would love to
questions you want.
hear, yeah, what is the best part of your job? What do you love most about what you're doing?
Let's see. That's a hard one. It's hard to make that sound not cheesy. But I do think the best part of my current job is just the people I get to work with, because like I said, it's the company I work at specifically is very people focused and very much into investing in the people I work with. And I am by far the youngest person on the team, so it's definitely a fresh perspective. It's a very different perspective, and it's so cool to see the people that I work with work and like the advice they have for me. Because again, like I said, I got into this whole space on educational robotics, platforms that I had in high school and stuff. I'm now working with the people who literally developed those platforms. So there's a lot to learn there. And every single time they add their expertise to the table, it's just like, I just think it's really cool.
Where are you located?
I'm currently in Fayetteville, Arkansas. So my office right now is actually called Startup Village. It's on Dixon Street in Fayetteville. So yeah.
That's
Are
awesome.
but you're part of a larger organization, so you're working remotely, or?
Yeah, so Sphere is a company.
Yeah. Gotcha.
It's the new normal.
We got a question asked, have we gotten to the chance to develop a free walking robot or a bipedal robot? Meaning, like, are we close to creating robots that think and walk independently?
I guess
Good
those are two
question.
questions. There's the think and walk independently, and there's the bipedal. I think, when it comes to think and work independently, that's a very open-ended question because it kind of depends on the circumstances and everything. But if you're talking about a robot to independently achieve a task, that's already been there. What becomes difficult is whenever that task becomes more open-ended and more complicated. And that's essentially the entire field of automation, right? It's kind of like how for years we've had really, really dumb robots that do one thing really well. Yeah, they do like simple thinking to check if things are in the way and stuff like that in automation. But now it's like when you start to make that target task more and more broad is when you have to do more and more thinking on the robot side. When it comes to the bipedal, where I think you're going with this is more like humanoid robots and robots that think and behave and act like humans. I think that technology is very far away, and its use cases are very niche at the moment. Yeah.
Well, so along the same lines, there are a lot of students out there watching. Is this what you thought you would go into? Like, is this what you imagined you would be doing at 22?
Not even close. Not even 4 years ago.
Right.
I think the end result is kind of similar. So yeah, I'm working as an engineer at a company. But whenever I came into college, I didn't even know what type of engineer I wanted to be. I just knew I liked the field of engineering. I didn't really even know what mechanical engineering was. I honestly didn't even know where I'd be going to college. I was like, oh yeah, I'm not going to UVM. I'm going out there. I was like, oh yeah, I'm never going to start a company. Or I'm not going to work at the same time at school. That's a lot of work. It's important to keep your horizons open, I would say, because there's a lot you don't know and a lot that can change. I think it's like a common trap that people fall into, where they try to plan way too far ahead. And yeah, it's like good and important to have those general long-term goals. Like it's necessary. You need to know where you're going. But the place that you are heading can kind of shift and change over time as opportunities arrive. And I think where a lot of people, don't realize their full potential is kind of like, well, this is where I'm supposed to go. This is what I'm supposed to do. They don't realize that slightly more risky, opportunity. Obviously, every student and everyone, you should always like have a backup plan, be knowledgeable in your decisions. Also, I think you need to take risks. And when you plan too far out ahead, you can kind of run into that trap of, no, I don't want to do that because I thought I was going to do this other thing instead.
And this you've kind of answered, or probably partly answered this, but what advice would you have for students that are interested in following in your footsteps? Maybe that's along those lines of, taking a risk or being able to start up a company at such a young age, but just what advice would you have for students
I would say
that are ambitious like that too?
I mean, even if you don't have ambitious goals, I wouldn't even say that I'm super ambitious. I just like doing things. But I would say try to surround yourself with a diverse group of individuals, just as diverse as possible. One of the most underrated things I think is, even like being friends with like one type of people or one group of people or interacting with one specific set of circumstances. The reason I am so well-rounded the way I am today is because of the way I like kind of force myself out there and to get interacted with people that are usually not. And when it's like you always learn things from that experience. There was a time whenever I was the most socially apt. I was a very quiet, shy kid, and like friends who break you out of that. And there's also whenever you are surrounded by people who want you to succeed, or people who are significantly, I don't want to say smarter, but like know things that you don't, you can always push yourself to learn more, and you're just set up to be more successful in the long term. And I think it's really important to remember that life is not linear at all. You're going to have some really high highs and some really low lows. And those low lows just might seem like they last forever in the realization, in the context of it. When you look back, it's really like not that big of a deal. And I think everyone always kind of jumps to sharing all of their successes because that's what they remember and that's what they talk about. But it's kind of like for every one success, there's a dozen or more failures. And success is really like an intersection between hard work and luck. I mean, it's not all luck, of course, but if you look at the timeline of what your decisions to make, it's kind of like a giant branching spider web. There's going to be like one path that gets you to the next step, but for every branch, it's going to be like 10 other avenues you could have taken or you did take and that just didn't end up anywhere. But you can follow that one thread of decisions all the way throughout your life that led to where you are. And that's the success route that everyone likes to talk about. That's not how it is. What works for one person is not going to work for the other. You just have to be willing to put yourself out there, explore every opportunity you can, and not be afraid to fail, I guess.
I love that. That's awesome advice.
Yeah.
We had another question asking, so what type of classes you mentioned the engineering class in high school.
Yeah.
And it sounds like you were and are getting back into the engineering program, I guess, at the U of A.
Mm-hmm.
What is that really? What other classes would you say you need besides engineering to be successful in what you're doing now?
I wouldn't say you necessarily need engineering classes. It definitely helps. But the most impactful for me were the classes that kind of lay that foundational role for knowledge you built up upon. I'm using physics as an example just because that's what I took, but it depends on whatever path you want to take. Because AP Physics 1, it's like, it's a project of course, but like compared to statics and thermodynamics and all these crazy advanced classes, it's just like really basic. But the important thing is I still all the time reference back to Physics 1, because that class is kind of what is like the broad general idea of how things work and how things interact. As long as you can tie things back to that, it makes a lot more sense going forward. Because those foundational classes are super, super important. And that can be sometimes difficult to identify in the moment. I would say, especially for me, math. I've always been like okay at math. I'm not super great at math. I don't love math. For a long time, I hated math. But it wasn't until I started using math in the context of physics and engineering that I was actually like, oh, okay, this isn't too bad. But like math in a purely theoretical concept is terrible. Like I hate it. But you kind of need those classes for anything else beyond it to make sense. And that's kind of like, you know, the scale of how your knowledge grows regardless. And even in these like more advanced classes that I take now, you know, I'll be taking like things like statics and stuff. And it's really rare that you will directly apply some of the more advanced like equations and concepts and stuff right now to what you're doing. But you use those general concepts all the time. You're not necessarily, you know, calculating bending loads for the specific part when you're designing it. But you're kind of like, oh, I should probably do this here because it'll have these impacts. And you kind of know like the proportions of how things will interact. So yeah, I hope that kind of gives a general answer. I feel like it's different depending on where you are.
You know, but that is great advice, because I think we, you know, I know as myself as a student and students that I talk to are in a class and they're like, this, I'm never going to use this, or this is,
Yeah.
and it isn't always that you're going to use it immediately, but it may be laying a foundation for something that you're going to be needing for later.
Exactly.
or whatever. So all
And
of
it's
kids
like
out there
about
that
the
are
big
listening.
picture, right?
Yeah,
Like
yeah. Right.
I still have not used probably 90% of the specific things I learned, but I've used 100% of the concepts I've learned.
That's awesome.
And so, you know, it's like, yeah, I don't need an equation sheet. I don't need to memorize a bunch of formulas. I don't need to do a bunch of things, but like that knowledge is so important. And I'd also say it's like, if you want to do one thing, it can be kind of dangerous to like just aim for that one thing, right? Like, oh, I'm an engineer. I'm just going to only take math and physics classes. Because I would say one of the most impactful classes that I took was like an art class in high school. And the reason for that is, and that's honestly one of the things that I think I want to improve on the most, because, you know, when I have an idea in my mind and I need to CAD it, there's a direct correlation between the fidelity of a sketch and how quickly and accurately you can design a model. Because the better your drawings are, the quicker you can see, oh, this doesn't work because of this, or oh, that's not going to work here, or oh, this is a better idea now that I see it sketched out. And, you know, even whenever you're designing, it's really important to not just design things functionally, but also artistically, because no one wants something that's ugly. It doesn't matter where you are. So, you know, you'd be surprised by how often those interdisciplinary classes actually come into play, regardless of what path you want to take.
That's awesome. So, what advice would you, so you gave this amazing advice for kids. What advice would you go back and give yourself at 12 years old?
I would say the two main things would be like, you know, identify the teachers who are not just there as teachers, but are there specifically. It's very good they're there because they care so much about you. You know, like those are the teachers that make a difference in your life.
Yeah.
And that kind of also opens it up to how you kind of have mentors as well. I think everyone that's always successful always talks about the importance of mentors. It's like, oh, you gotta go out and get mentors. It's like, how do you do that? And I myself have like tried to like reach out to people for mentors and stuff like that. And you know, it's like kind of just like a weird casual conversation. It doesn't really go anywhere. And that relationship is like kind of empty. But the mentorships that I would like actually credit significant impact on my life would be either former teachers or former coworkers or former natural connections that I made that, you know, just end up being more and more important. And I think there's like two kind of distinct categories of mentors. There's the short term where they're super impactful and really important. But, you know, kind of like they're only there for like one phase of your life or one part of your life or one thing that you're doing. And then there's the other type that, you know, is kind of like always in contact, and you have significantly less of those. You know, I've had mentors, like I had like one of my English teachers as a great mentor all throughout high school and a little bit of college. I had one of my art teachers as a mentor just because, you know, we're really committed to design. And like I've had some other interesting mentors like bosses and stuff like that. But I'd say like one of my main mentors that has helped me significantly, opened a lot of doors for me, was my engineering teacher out there at high school, who I'm still in contact with to this day. I mean, I'll still go back and talk to the class and stuff. And, it's like, it's not like a super close connection that you reach out and text every single day. It's like, you have those moments where you talk to each other every week or so, and you have those moments where you don't talk to each other for 3, 4, 8 months, but then you just like reconnect and update. And those are the opportunities that really open up my doors for you.
I love that. That's awesome.
Well, I want to thank you, Kaushik, for giving us your afternoon and giving us some aged advice from such a young person. That I'm like, if I were as mature as you when I was your age, I would have not made as many mistakes.
Well, wait, Dustin, I'm not sure you're mature as him. You're
Okay.
Don't let me fool you. I still don't know what I'm doing.
Well, but it's nice to hear that you're very successful. You're very driven and highly motivated. And I think your advice about finding teachers or finding mentors is very much needed right now, because we know kids are kind of lost. They've been virtual and hybrid and on-site, and they need some direction. So I think that's very wise and sage advice of you. So thank you for giving us your time this afternoon. For anybody that just joined in between, we are recording. This will be live on our Facebook page, our Northwest Arkansas Education Service Co-op, the Facebook page, but we'll also have it recorded and share it out with you in little YouTube clippings. But thank you again for joining us. And we will be back at 1 o'clock for our next Real World Wednesday speaker.